Let's say we have a random function f at x, and we want to rotate it about the y-axis to generate a solid. Besides using disks or slices, we can also use the method of cylindrical shells to find the total volume of this solid. How this works is, so let's say this is the base of the solid. We would break the solid up into cylindrical shells. So that would be a cylindrical shell. This would be another cylindrical shell. And so on. So we basically have, if we look at it from the tip of the y-axis, let's say this is the top of the graph, so the tip of the y-axis, and we look down, we will have a lot of shells like so. And eventually when we add up all the shells, we will get the total volume of the solid. Let's draw out every shell first. So let's say this is a cylindrical shell. We can basically, like a piece of paper, cut this and open it up, so then it becomes more of a rectangular prism, which is easier to calculate the volume of. The thickness of this piece of paper is equal to the thickness of the slice of the shell. And from the graph, we know that we want a very small x value, so it will be dx. And this length correlates to the circumference of the shell. And we know that circumference is pi times the diameter. But diameter is 2 of the radius, so we will write it as pi 2r. However, from this graph, we can see that the radius is from here to here. And on the graph, it correlates to the middle to wherever the cylinder reaches. So basically the x value. Therefore, circumference is pi times 2x. And then the height of it has to be taken into account also. So altogether, the volume of every slice is pi times 2x times h times dx. But we have to add up all of these slices. So our total volume is from A to B 2 pi xh dx.